So we are here in a coastal environment in Victoria, Australia, and we are tracking birds because we want to understand their habitat and how they use this habitat. We want to understand their behaviour throughout the day and at night, where they forage, where they roost when it's high tide, so we can have a clear understanding of what is their key habitat for their survival. We have some species that we study that will breed they will disperse when they breed, like the black swans, for example, or species like the terns that breed in colonies. We want to understand what happens when they don't have access to their foraging habitat. So in a coastal environment, it's at high tide, the birds can't forage on mud flats, for example. So we want to understand what are their important roosting sites. A roosting site is where they stay during high tide. So we are tracking 5 species of birds that can occur in this environment, and we can't catch all the species. So we decided to catch 5 species that can represent as much as possible all the species. So in a coastal environment, we have shorebirds, migratory shorebirds, the red-necked stint. We have the pied oystercatcher, species relying on seagrass beds, the black swan. And we have then 2 species of seabirds, a coastal seabird, the crested tern, and a seabird that is more likely to forage offshore, the short-tailed shearwater. So all these species together will give us a good understanding on what habitat is very important at the scale of the community, but as well at the scale of each of these species. So this information can be very useful for a client and a specific project because we gather very specific information compared to other methods, and we gather a tremendous amount of data which is very valuable to map habitat, for example, or to have a clear understanding of their behavioral patterns. For example, what do they do at night or what do they do during the day, which is much harder to gather with traditional methods. Some research projects shown that a minimum of 2 years of data is very essential to understand the habitat use of this species, but it's also likely that we'll collect good enough information with only 1 year of data. It depends also on the species and the methods that we're using. For some species, we deploy devices that are going to last just for a few weeks or a month. For some other species, like the black swan, we collect data for a year or more for each individual. So the traps we are using to catch oystercatchers and red-necked stints, for example, are very simple and kind of archaic. It's just making mats. The bird is going to walk on the trap and get caught, and then it can't fly away, and we just come and grab the birds and release the leg, and then we can process the birds by deploying a device. It's quite a small device, and it's simply because we don't want to burden the birds. The general consent is that we don't deploy devices that are more than 3% of the body weight of the birds. For an oystercatcher with a device like that, we are way lower than that limit. We are around 0.5 to 1% of the birds. The trapping methods and the devices that we are using are species specific. So we work on methods that are targeting exactly the species that we want, and we won't catch more birds than what we need.